Hello dear aspirants, this is Dr. Saurabh Sir's classes. Our contact number is 98367930076. Again, I am repeating our contact number, which is 98367930076. And you can drop an email to our email ID, which is saurabhsirclasses@gmail.com. So if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. Then you can join as a student to our institute, and then you can enjoy all the services of Dr. Swarov's classes. Like you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming mathematical examinations or any other examination. So this question is for the JELET aspirants, and if you are applying for JELET, so please uh, look about this question. And the question is from the JELET 2024, and the question is telling us that A equals to 3 minus 4, 4 1 minus 1, a 2 cross 2 matrix, then A to the power k, where k is any positive integer, is there are four options here. So what is the option? Okay, so firstly we will have one thing, that is our the given matrix is A. So let me write the matrix again, that is 3 minus 4 1 minus 1. Okay, so and asked that, so they asked us to find the a to the power k. Okay, so now we to compute a to the power k, we can use diagonalization is if our a is diagonalizable. Okay, so let's proceed step by step. So now check if A is diagonalizable or not. So a matrix A is diagonalizable if it has two linearly independent eigenvectors. To check this, we first find the eigenvalues and the eigenvectors of A. So now we are going to find the eigenvalues. So we have to compute the characteristic equation first. So that is the determinant of A minus lambda I. Okay. So that will be what now? That will be determinant of 3 minus 4 1 minus 1 minus lambda 0 0 lambda, and after that the determinant closes, that is equals to 0. So then we will get determinant of 3 minus lambda, that will be minus 4 here, and after that we will get 1 here, and that will be minus 1 minus lambda, that is equals to 0. So now we will get the determinant of A minus lambda I will be equals to what? That will be 3 minus lambda into that will be minus 1 minus lambda minus of minus 4 into 1 is equals to 0. So we will get what? So now we will get the minus part will be common, or after that we will get lambda square minus 2 lambda plus 1 is equals to 0. So we can say that our lambda is equals to 1 with multiplicity 2. Okay. So now our eigenvectors. So now for our lambda equals to 1, the eigenvector will be what? That will be, so for finding eigenvector, we have to solve this equation. A minus I v equals to 0. So then we will get what? A minus I will be, that is 2 minus 4 1, and that is our minus 2. Okay, so the system of equations will give us what, as we are multiplying with v1 and v2 and we are getting 0 this side, so we will get 2v1 minus 4v2 is equals to 0, and v1 minus 2v2 is equals to 0. Both equations are equivalent to v1 equals to 2v2. Thus the eigenvector corresponding to lambda equals to 1 will be what? So our v is equals to 2 1. Okay, so since there is only one linearly independent eigenvector, so our A is not diagonalizable. So now we are using the Jordan form. So as A is not diagonalizable, we will use the Jordan canonical form, and the Jordan form of A will be this. A equals to, now that will be P inverse. P inverse. Okay. So after that, what we will get now? So where our J is the Jordan matrix and P is the matrix of generalized eigenvectors. So now for A, the Jordan block will be what? The Jordan matrix will be 1, 1, 0, 1, as they are sharing a single eigenvector. Yes, a single eigenvector. Okay. So now the matrix P is formed using the eigenvector and the generalized eigenvector. So as our V2, sorry, as our V1 is to 1, and after solving A minus I, V2 is equals to 0. So again we will get what? Again we will get the same linear conditions. That means 2V1 minus, sorry, that is 4V2 is equals to 0. So we will get after that V1 minus 2V2 is equals to 1. So now solving this, we will again get our V2 will be 1, 0. So thus the P, so thus our P is now 1, sorry, that is 2110. Okay, so now we are going to compute A to the power K. So now using the Jordan form, we can write that our A to the power K will be P K P J to the power K P inverse. As we have, if we will write P inverse, P inverse, then P inverse P will be identity. So we finally get A to the power K is equals to P J to the power K P inverse. So now that will be what? So our J to the power K will be J to the power K, which is equals to our 1 to the power K, and that will be K into this thing, and 0 into 1 to the power K. So we will get 1K01. So now we are going to next computing P inverse. So P inverse is our equals to, or rather that will be 0, 1, 1, minus 2. Okay. So now we are going to compute A to the power K. So our A to the power K will be what? That is now equals to 2110 into 1K01 into that is 011 minus 2. So firstly we are multiplying this first two, we are computing this matrix multiplication, then we will get the whole thing will be 2 into 1 plus 1 into 0, 1, 1 into 0, and then we will get 1 into 1 plus 0 into 0, then we will get 2 into k plus, sorry, the k will be bigger one, 1 into 1, and then 1 into k plus 0 into 1. Okay, so finally, so finally we are getting 2, 2k plus 1, and that will be 1 and k. Sorry. So now after this we will multiply with, this with the last thing. That means we are now computing these two multiplications. So we will finally get that will be 2 into 0 plus that will be 2k plus 1 into 1, that will be 1 plus 0 into that will be into 1, that will be bigger k, sorry, k plus 2k plus 1. Yeah, so now we will get here 2 into 1 plus 2k plus 1 into minus 2, and now we will get 1 into 1 plus k into that will be minus 2. Okay, so after computing these things we will get 2k plus 1, then we will get k only. This side we will get 2 minus 4k minus 2, then we will get 1 minus 2k. So finally we will get 2k plus 1 minus 4k this side, sorry, minus 4k, and then we will get k here, so this is 1 minus 2k. So this is the correct answer of this question. So what is this option? So our this option is in our option A. Okay, hope you understood, guys. Again, I am telling that if you have any other mathematical query or doubts or anything, so please feel free to contact on this number. That means you can WhatsApp or you can call also, and you can use the email, or you can drop an email to our email ID. Then you can enjoy all the services of Dr. Swaroop's classes. Okay, thank you, guys. Hope you understood. Thank you.